Hi, everyone. Thanks for joining today's live action webinar, Best Practices to Optimize Your SD-WAN. I'm Monique Lucy, Director of Product Marketing at Live Action, and I will be your host today. I'm also joined by David Izumo, Principal Technical Marketing Engineer here at Live Action, and he will be giving us a demonstration shortly. In the meantime, please feel free to ask questions during the session using the Q&A panel on the right. And this session will be recorded so you can go back and watch it again. You'll receive an email with a link to the playback after this event. And then we've also shared some additional resources in the attachments tab. So with that, I will turn it over to David for the demonstration.
In the last webinar, we reviewed how a network administrator can use Livenex to verify SD-WAN policy intent and troubleshoot a brownout scenario. Now, in that brownout scenario, we identified how traffic was out of policy on the primary MPLS path and verified that critical applications like voice over IP were moved over to the business internet transport. In this case, the brownout was caused by high network delay, and all of this troubleshooting was done in a simple 3-click button click process. Today, we'll look further into Day 2 operations management with Livenex. We'll focus specifically on SD-WAN, but many of these concepts will apply to general WAN and network operations. So first off, let's review the engineering console, which is being displayed now, and let's look over some of the basics. Now, Livenex, the mentality was to recreate the mental model of the network engineer. So in this case, you can think of this engineering console kind of like a dynamic whiteboard or a dynamic Visio diagram. The big circles represent routers or switches or firewalls, basically any network device. And I'm zooming into this topology using the scroll button on my mouse, or you can use these magnifying glasses here in the upper left-hand corner. Now, very easily, you're able to also identify the interfaces within the network device. So for example, this is Gigabit Ethernet 2. It's a WAN interface connecting to the MPLS circuit. The bottom portion of this interface is egress bandwidth. The top portion is ingress bandwidth. Now let's look in a little bit further to get a good understanding of the constructs that are used within Livenex, specifically with IPFix, NetFlow, SFlow, or any flow technology for that matter, to identify all of the conversations and the applications. So let's go ahead and double click on this router out in Seattle. And now we're going to look at the real-time network view. Real-time IPFix is coming in to Livenex, being collected by Livenex for this particular device. So we see all of the conversations, including source and destination IP addresses, the application name, which is really important, especially in modern networks today, along with the ingress and egress interfaces, the DSCP values, and so forth. Interestingly, we also are able to get things like the HTTP hostname as well as the SSL common name. Now, this is the basic flows. We're looking at the typical 5-tuple of information: addresses, port numbers, DSCP values, and so forth. But now what we're also able to do is pull in voice and video performance data as well. So I'm going to pause this for a second. And we're looking at the same device, but now we're looking specifically at voice or video application performance metrics. So we still see the source and destination IP addresses as examples, the application names, but now we're also seeing application performance. So in this case, for certain flows, there's high packet loss percentages, up to 2.36% or even close to 40% packet loss on some of these conversations. Likewise, there's the jitter values and various other KPIs specifically to voice and video, including the SSRC value for the RTP traffic. Now, this is the voice and video application performance. But likewise, from this same device, we're also able to get application response time metrics. So this is typically for TCP-based applications. So again, we see the source and destination IP addresses, but now we also see application names like YouTube, Netflix, Salesforce, Outlook Web Services, and likewise, we're able to get detailed information about network delays, application delays, client network delays, and so forth, right? Including things like HTTP host names and SSL common names. So all of this is being pulled directly from the routers themselves. So I'm going to pause here again. So now we're able to really see some of that network delay, round trip times, and various other KPIs that's very specific to modern applications today. Now, the reason why I'm going over all of this is because these are some of the underlying constructs that's needed to really make sense of the network from a day two operations perspective. So let's go back to the home view, and I'm going to zoom out just a little bit. And again, I'm using the scroll button on my mouse, or you can use these magnifying glasses here in the upper left-hand corner. Now, Livenex, you can think of this kind of like a Google search for NetFlow. So, for example, if you want to look specifically at a certain site or an IP address or an application, you can simply type that into this filter bar or this search bar at the top. We call this Flex Search. So in this case, I'm going to look at a specific IP address. Perhaps there was a call into the Network Operations Center, and we want to identify a specific IP address because there was some application performance issues. So I pressed enter, and now we're seeing specifically a conversation for this IP address. It's originating in Seattle. It's going across the MPLS circuit off to our data center in New York. Now, in this case, we see that it's voice traffic, as we see in this legend down in the lower left-hand corner. But likewise, what I can do is I can also change the display filter to DSCP. Now, notice this is why there could be some voice quality issues for this particular conversation. Notice that all that traffic is primarily being marked EF. It's showing up as red. This is best practice for voice over IP. But also, interestingly enough, as the traffic is egressing the MPLS service provider, we're seeing that traffic is coming in the cyan color, and that cyan color represents best effort. So there must be some remarking of the traffic within the MPLS network. We can then use this information to remark that traffic accordingly at the Seattle router, leveraging quality of service, or possibly also going back to the MPLS service provider to identify and open up a ticket to understand why that traffic is being marked by the provider. So this is just a brief overview of the logical topology in our engineering console. So network engineers can use this as a deep dive. You can look for very specific flows, conversations, look specifically at the routers and see all of those flows going in and out of the system in pseudo real time. But let's switch gears and let's move over to our operations dashboard. So I'm going to switch over to our web UI. And in this case, when you first log in to Livenex, the operations dashboard, you're presented with this overview page. Now, we looked at this a little bit earlier in a previous webinar, but just as an overview, notice that we break it down into all of the sites, the devices, the interfaces, along with active alerts. Now, what's very good about Livenex is we allow the user to take advantage of filters. So for example, if you want to focus your attention on a specific region, maybe North America, you can simply use that region filter, type in North America, it'll autocomplete and apply that filter. And then everything on this dashboard will converge around that region. Now, perhaps you want to focus your attention on specific sites within North America. For example, it could be the New York site along with the Los Angeles site. I'll just type in LOS, it'll autocomplete and apply that filter here. So now we're looking specifically at these two sites within North America. Now, just for some background information, filters of the same type are evaluated as a logical OR operator. So in this case, because we have two sites within the site filter, we're basically telling Livenex, look for all devices or information about New York or Los Angeles. Now, filters of different types, for example, region and then sites, those are evaluated as a logical AND operation. So in this case, we're looking specifically at region North America, and logically, from an AND perspective, I also want to look at sites New York or Los Angeles. Let's add to this. Perhaps you may want to also focus your attention on a specific service provider, perhaps the MPLS network. So I'll type that in, and then it'll autocomplete, and I'll apply the filter. Now we're looking specifically again at these specific filters, the North American region, New York or Los Angeles, and we're going to look specifically at the MPLS service provider. So there's less interfaces shown. These are the WAN interfaces tied to Los Angeles as well as New York. Now let's drill in further specifically to the Los Angeles site. So I'll go ahead and click on that, and you click on that Los Angeles site and it'll automatically bring up the site entity page for Los Angeles. And at a glance, we can see the details, where this site is located, again, Los Angeles, the geo coordinates, along with specific information about the business hours and so forth, including the address if it's provided. Now, as I scroll down, we provide at a glance very specific reports about this site. So for example, here's the service provider bandwidth, inbound and outbound. The top applications like YouTube, Google Docs, voice over IP, perhaps someone's watching the basketball game or the football game. ESPN video is there too. Along with outbound applications, the DSCP markings for QoS, along with the top conversations, both inbound as well as outbound. And then likewise, we can check on the availability of the site. And fortunately, everything's running really well. The site is up. Along with the device list for Los Angeles, we have two devices that's also represented on the right-hand side with this logical topology here, where we can see that the Los Angeles router is connecting directly off to that MPLS service provider, along with the interfaces and the WAN applications. So these are all the applications that are seen in this Los Angeles site. Now let's focus our attention specifically on a critical application, voice over IP. So I just typed that into the search bar and it brought up voice over IP. I'm going to go ahead and click on that and it'll automatically bring up this voice over IP page specifically again for site Los Angeles. Notice we have application performance metrics. There's the jitter values, 26 milliseconds, along with packet loss. So we're seeing some high packet loss specifically for this critical application voice over IP. Anything over 1% packet loss will definitely have a poor quality of experience potentially for those conversations at this site. Now, all of this data for application performance is being derived by IPFix, directly from the routers, the network devices, or also from our packet capture and analysis products, Livewire or Live Capture. Now notice also we can see the voice applications shown on the logical topology for the site on the right-hand side. So here's Los Angeles, that router, and then again, it's all connected to the MPLS service provider. Everything looks green, so the performance is very good, as we see in the legend, going out the service provider to the New York site. But as traffic's coming back from the New York site, notice that it's showing up as red. As I click on that flow, we can see that it's really caused by high packet loss at 10%. That's really a problem. So very quickly and easily, we're able to drill down from a high-level dashboard into the site and evaluate a critical application like voice over IP. So now let's look further at other dashboards that are available within Livenex. Now there's many dashboards that are built in to the system, along with dashboards that could be created by the end users, the network administrators, and shared with others. The way that you'll get to dashboards is by clicking on the menu button and then clicking on dashboard. Now in this particular case, I wanted to show the application dashboard. We looked at this a little bit earlier. So here's a custom built dashboard specifically for applications in the environment. Top applications, for example, in this widget in the upper left-hand corner, the top web servers, along with SSL, common name devices or secure service servers within the environment, application network delay, voice and video performance details, along with site capacity utilization by service provider. Now, the dashboards are dynamic in nature. You can put whatever widgets that is of interest to you. You can also resize these widgets as well by simply dragging it to resize. Now, likewise, you can move these widgets as you see fit. So for example, if I wanted to move the top applications widget into the middle here, you can easily do that. Now, each one of these widgets, you can click on the heading and it'll automatically bring up a report. So let's go ahead and click on top applications. So by clicking on that top applications widget heading, we're automatically brought into a specific report. Now here we see all the top applications within our environment. We see Voice over IP, Citrix, YouTube, Outlook Web Services, even Netflix. Now, each one of these reports, you can continuously drill down to evaluate more details. So for example, if I wanted to look further at Voice over IP and maybe see how this critical application is being marked from a QoS perspective, simply right-click on Voice over IP and drill down on it as DSCP. So I'll go ahead and do that. It'll automatically bring up a new report. Now this is specifically looking at the flows for voice over IP applications. And now we can see very confidently everything is being marked EF based off of best practice. Now perhaps we wanted to drill down further. Maybe I want to identify what the top conversations are. I can simply right click on that DSCP value again and then drill down as top conversations. So again, the Livenex backend is looking at all the data, and now we're seeing all of the conversations specifically for voice over IP and those conversations that are marked EF. So we see traffic for Seattle, Birmingham, Austin, along with Los Angeles. So again, Livenex is able to provide dashboards and continuous drill downs in the reports to really identify areas of interest on the network. The next dashboard that we'll review is specific to SD-WAN performance. So let's go back to the dashboards. Again, we do that by clicking on the menu button to main and then selecting dashboard. Now in this case, we'll look specifically at the Cisco SD-WAN performance dashboard. The way that this dashboard is broken up is by the three main areas of interest or the dimensions of the WAN when you think about a wide area network. Now when you think about the WAN, you think about your sites, you also think about your service providers, and then also your applications, or in this case, the SLA classes for Cisco SD-WAN. So by looking at all of that data and outlining it by performance like jitter, loss, and delay, we're able to really understand at a glance the performance of the Cisco SD-WAN network. So notice, for example, here's the site-to-site performance that has the highest amount of delay. Right? So there's Chicago to Miami, along with San Jose to Chicago. The service provider that's having the most issues is the MPLS provider. Why? Due to that peak delay of over 300 milliseconds. And then likewise, which SLA classes are having the problem? It's voice video as well as web SLA. Why? Again, we see it's because of delay. Now, just as in the other dashboards that we looked at earlier, you can easily click on the widget heading to drill down to a report, or likewise, you can click on any of the site-to-site information, and this will automatically drill you down into a Sankey diagram that we looked at earlier in the previous webinar. So for example, if we wanted to troubleshoot what's happening from San Jose to Chicago, I can simply click on this row, and it'll automatically bring up the site-to-site Sankey diagram shown here. So notice that here's all the traffic from San Jose to Chicago. There's all the applications, the segmentation, which is the VRF10 or the Service VPN 10, the QoS markings or DSCP values, the service provider path that it's taking, along with the tunnel performance tied to these service provider transports. And like we did in the previous webinar where we're troubleshooting a brownout, you can simply click play and all of this will animate over time, showing you how that traffic is being moved from one provider to the next. Very easily viewed to understand what's happening during this time period. Now I'll reset this Sankey diagram and recall that you have that continuous drill down. So in this case, if I just simply click on the MPLS service provider, it'll automatically bring up the reports like we saw last time, application reports, DSCP value reports, top conversations, along with the performance. Now that performance really had high delay. So notice that this last graph showing a round trip delay is actually a critical issue. Just as we saw on that first dashboard where we identified latency as a primary issue. Now, just as we're able to drill down from dashboards into Sankey diagrams and additionally to reports, a network administrator or engineer is also able to create reports within Livenex very easily. So now that we're looking at this drill down report from the MPLS service provider, to get to reports, you can simply click on Create Report in the upper right-hand corner, or likewise, you can go to the menu button and go down to Reports and View Reports. So let's go ahead and click a new report. So here you're presented with the Create Report UI. There's many different reports that are available. Top reports like applications, top conversations, DSCP, flows, and so forth. So for example, if I wanted to add a report, I can simply click on application, for example, set the time range, maybe 15 minutes or perhaps a day, and then also set things like that flex search. So if I wanted to look specifically at a site, I can do that very simply and easily too. By pressing execute, it'll automatically run this report ad hoc. Now, likewise, we can create a whole list of reports to run within the system. So for example, I created a template here for SD-WAN applications and performance. Likewise, for these reports, you can share it with your colleagues or keep it private in this example. But you know what? I'll go ahead and click public so that I can share it with others. Now I'll click on this template and let's review what we can do with the reporting within Livenex. So notice by clicking on that template, we see all the reports within the list. Applications, DSCP. I specifically looked for applications for the site San Jose using that flex search. You can likewise also set custom time ranges, or like we looked at earlier, perhaps just look at that last day. Now, likewise, if you're really looking into Cisco SD-WAN as an example, you may want to leverage this site-to-site performance over time report. Now, this report is very interesting in the sense that it allows a network engineer to look at all of the Cisco BFD tunnel data for performance metrics that reports on loss, jitter, as well as delay, set a threshold, and then a violation duration, so in this case 1 hour, to identify how often these tunnels were out of threshold based off of this custom setting for the time range, in this case 1 day. So we'll go ahead and run this report in just a little bit. And then likewise, I also added in a report for service provider performance as well. Now, once you have this report list, you can move these reports up and down within the list to make sure and identify how you want that list of reports to be evaluated upon or presented to the end user. You can then update the template or save the template. Now, in this case, I'm just going to go ahead and press execute. Now, Livenex is looking at the backend. We're looking at flow data along with BFD data, which is derived by our northbound API connection to vManage. And here are all the results. So now as I scroll down, here's all the applications along with the DSCP values, the service provider performance. So specifically for MPLS, notice that everything is normal for loss as well as jitter, but it's a critical issue when it comes to delay at over 300 milliseconds. Now, likewise, we looked at that site-to-site performance over time. So in this case, we set a violation duration of 1 hour and then the delay threshold for 150 milliseconds. So for the top site-to-site traffic or tunnels on this MPLS service provider, we see the time in violation along with the longest violation duration. So for 25 minutes from RTP to Chicago, or likewise from San Jose to Chicago, there was a violation of 25 minutes, which was the longest period of time. So you can think of this report and allow network engineers to be able to run different scenarios based off of historical data to identify how often various tunnels are in or out of threshold based off of custom parameters for delay, jitter, as well as packet loss. Now, as I scroll to the top, each one of these reports that you set up could be shared, it could be downloaded, along with scheduled to be run regularly, maybe every day or every month or so forth. Now, interestingly, you can share these reports with someone that doesn't even have a login to Livenex. So for example, I'll just click on this share button. That URL was copied to the clipboard. And then I'm going to bring up a incognito browser. So in this case, I'll go straight to that browser. I'll type in the shared link that might be shared either via Slack or messaging or an email to somebody that may not even have a login to Livenex, and you can share this directly with that individual. So I'll go ahead and press enter. And now we're able to see all of the results for this specific report. So imagine if you're a network administrator or an engineer and you want to create a whole list of reports for consumption by the executives within your organization. You can simply share a link, and as long as the person that you're sharing that link with has access to the server, or they have reachability to the Livenex server, they can easily see all of the report results for this set of reports. Right? So there's all the reports again that we looked at earlier. So all of this reporting capability is very powerful within Livenex. Now let's look back at the geotopology, and let's look a little bit further. We looked at that earlier in a previous webinar, but let's see how we can leverage the filtering capabilities, the views a little bit further to really identify application traffic, tunnel performance, and so forth. Now, the way that we get to the geotopology is by clicking on the menu button again. That menu button is your friend. We'll go down to topology and then select geotopology. So now here's that geotopology that we looked at earlier with our various sites: San Jose, RTP, Chicago, and Miami. Now, on the right-hand side, there's a display mode. Here you can select applications, SD-WAN tunnels, along with application performance, VQoE. This is for Cisco SD-WAN Cloud On-Ramp for SaaS. Now, if I take all of these and untick each one of these selections and press apply, we're going to look specifically at all the sites on that geotopology. And each one you can bring back specifically to identify perhaps all of the application flows, and then maybe adding in something like the SD-WAN tunnel performance as well. Now, every one of these applications are shown in the legend down in the left-hand corner, and you can select an application from the legend and it'll display on the geotopology. So for example, here's all the voice over IP traffic, Netflix, SAP, Outlook, and so forth. Now, as a frame of reference, just as a review, we also bring in the policy from Cisco SD-WAN via the northbound API connection to vManage. So just to refresh our memories, notice that there's two SLA classes, Web SLA as well as Voice Video. They have a latency threshold of 100 milliseconds for Web SLA and 50 milliseconds for Voice and Video. The primary path for the Voice and Video class is MPLS, and the secondary or the backup is Business Internet. So now recall that we were able to click on that aggregate tunnel performance from San Jose to Chicago and see all the details, right? So everything's fine on Business Internet, everything's green, but on the MPLS path, we see that there's high delay, over 200 milliseconds. We saw this earlier also on the dashboards and the reports. But now let's also look further at the filters. We looked at the filters in the dashboard scenario, but on the geotopology, we actually added a lot more. So for example, if you wanted to look specifically at traffic from to and from sites San Jose, as well as Chicago, you can add that into the filter, click apply, and now we're only going to look at traffic from San Jose to Chicago. Now, perhaps you may want to look specifically at source site traffic to a specific set of destinations as well. You can do that very easily as also. So I'm going to go ahead and remove this site filter, and now I'll also use this source site filter. Now I'm going to choose the operator equals, but you can also choose not equals or bang equals if you want to remove a source site from this geotopology. But in this case, I'm going to go ahead and say equals, and I'm just going to look for source site San Jose. And now from San Jose, I may want to look specifically at particular destination sites, maybe Chicago as well as Miami. So I can apply that filter, and now Livenex is looking at the backend and we see all of those conversations, voice over IP, SAP, and so forth, ICMP and many other applications. But now notice it's one way from source San Jose to these destination sites. So Livenex can be leveraged by network engineers to really do a deep dive into the application traffic and visualize it on this geotopology. Let's take it a step further. Let's also look specifically at maybe the service provider business internet. So I'm going to add the filter for service provider and choose business internet and apply that filter. Now notice now that these aggregate tunnel performance is green because we're focusing our attention on business internet. Recall that MPLS was the service provider that really had an issue. So again, leveraging these filters are very, very powerful. Additional filters that are available, I'm going to go ahead and clear these, are the SLA classes. And notice again, with SLA class, you can use an equals operator or a not equal operator. So perhaps if you wanted to focus your attention only on the voice video SLA class, you can go ahead and do that also. So we'll go ahead and do that. I'm going to go type in voice video. SLA class, voice video, and press apply. So very quickly, you're able to really zoom in on specific pieces of information of interest to the network engineer. Another key use case in day 2 operations and management is WAN capacity planning. And we have a specific workflow or what we call stories available within Livenex. So we'll go to the menu bar and then we'll click on stories and then select WAN capacity planning. Now this will automatically bring up our WAN capacity planning story. What you see here is helping network teams get ahead of any bandwidth limitations at their key sites and service provider connections. Now Livenex has a full WAN capacity planning story as you see on the view now. And this workflow helps teams to quickly identify 6 months of data at a glance for the highest utilized sites and transports. So for example, at the Seattle site, notice that we've been overutilizing the primary MPLS circuit for the last 6 months. And by simply clicking on any one of these cells, specifically to a month, we can get more details. Now, each one of these cells represent the 95th percentile utilization for these sites and service providers. So now let's go ahead and click on the Seattle site for November on this MPLS circuit. We'll automatically bring up a whole set of reports to help the network engineer understand what's happening from a utilization perspective. So there's the interface bandwidth, inbound as well as outbound, both the 95th and 99th percentile bandwidth calculations. Here's the interface errors report. along with interface utilization. So inbound, we see that it's not used as widely, up to about 53% and a peak of 85%. But really where we have an issue is the utilization goes all the way up to even almost 300% utilization at the peak. So there's definitely some bursting of traffic, and we need to upgrade the capacity of this link. Now here's information about QoS, along with application traffic, DSCP conversations, and so forth. Right? Now, Livenex also has full detailed capability, not only for WAN capacity planning, but also with our Live NA product for live network analytics. We can help network engineers and administrators identify, based off of machine learning, when these links will be approaching their bandwidth capacity limits, and also predict in the future when these circuits are going to get overrun. So that's something that you can also take a look at within Livenex. Now, the final use case that I'd like to go over today is really around alerts. So you can get to alerts by simply clicking on these, the alert buttons at the top. And I'm going to go ahead and click on the critical alerts here. Now that'll automatically bring up all of the active alerts that are seen by Livenex. Now, obviously, our network teams are extremely busy. They're being asked to do more with less, as I'm sure all of you are being asked those same things. And network teams cannot be looking at dashboards or reports continuously all day long, even though for us at Live Action, we'd love for you to continuously look at our dashboards and reports and visualizations. But really, that's not practical for network teams. As a result, they need to rely on alerting capability. Now, Livenex has full alerts for network utilization, device CPU and memory usage, application and network performance, and full Cisco SD-WAN alerting too. Now, these alerts can be emailed or integrated to third-party ticketing solutions like ServiceNow or PagerDuty. And of course, you can triage these alerts directly within Livenex. So again, we're looking at the critical alerts along with all active alerts within the system currently. You can refresh the alerts and also search for the alerts based off of this search at the upper right-hand corner, or for each one of these columns down below. So let's look a little further on how to configure these alerts. So you can simply click Configure Alerts in the upper right-hand corner. And now we'll see all of the different alerts that can be configured. And it's broken down by category and alert type. The category, you can think of this kind of like a high-level category, high-level group of alerts. And then each alert type is a specific alert and KPI being measured. A relatively new capability that we introduced to Livenex is the ability to report on alerts, both historically as well as active alerts. Now, the way that we'll do that is we'll go back to reports. So I'll go ahead and click on the menu button again, go to reports, and then view reports. Now I can create a report and then identify specific alerts that I'd like to report on. So I'll go ahead and click Create Report, and that'll bring up the Create Report dialog. And let's focus our attention specifically on alerts down below. It's broken up into active alerts and as well as historical alerts. So let's focus our attention on active alerts by type. And in this case, I want to look at active alerts types by site. So I'll go ahead and type that in or select that report. And what's nice is we also allow you to use Flex Search for alerts. So for example, if I want to look specifically at a certain alert type, perhaps voice and video, I can easily do that here. So I'm going to look at voice video performance specifically for packet loss. And then simply click Execute. We'll run that report and then identify all the alerts for voice and video performance based off of packet loss, and all the top sites for this alert will bubble up to the top. So there we see New York, Los Angeles, Birmingham, and so forth. Now notice specifically Los Angeles has 3 critical alerts for voice and video performance. So let's dig in further and identify more information about this issue in Los Angeles. And what I'd like to show is then drilling down from alerts all the way down into the flows and into the packets as well, leveraging our packet capture and analysis capabilities. So let's go back to the active alerts. I'll click on critical alerts at the top, and this will automatically bring up all of the alerts again, the active alerts. Now I'm going to go ahead and focus specifically on Site Los Angeles, and I want to look for any traffic that's voice over IP. Now there's something of interest. So Los Angeles, the voice over IP application traffic is running at 10.6% packet loss. So I'll click on that alert, and we're bringing up all of the details. So any one of these orange items can be drilled down upon to look further. So if we want to dig in specifically to Site Los Angeles, I can do that. Or maybe the source site, New York. In this case, I want to focus your attention specifically on the conversation of interest. So there's the 5-tuple data, and I'm going to go ahead and click on that conversation. It'll automatically bring up a site, a flow path analysis to really dig into this voice over IP application and identify all the hops that this traffic took within the network environment. So notice that the traffic originated in New York, and then it went across the MPLS network into Los Angeles. It likewise hit the Los Angeles router along with the Los Angeles live wire for our packet capture and analysis. Now, specifically, notice that there's high packet loss for Los Angeles, 10.4% packet loss or so, over 10%. But perhaps I may want to drill down specifically onto the packets. Notice that there's this little peak button here, and it'll automatically cross-launch into our packet capture and analysis capability. So we're automatically cross-launched to Livenex Peak, and we're looking specifically at the conversation we're looking at earlier for that path analysis. There's the source address, along with the destination address, port numbers, and so forth. So we're not looking at all the packets, but we're really trying to find that needle in the haystack, the specific flow that we're troubleshooting from the path analysis. And now I want to dig into the packets themselves. So I can start this forensic search, and we're automatically going to bring you in to the Live Action Peak software to do the packet capture and analysis. So notice specifically for this one call, there's high packet loss, over 10%. The call quality is poor on 100% of the calls because this is only one call. We're finding that needle in the haystack. You can think of this kind of like a scalpel looking specifically for something of interest. The MOS score is very low as well. Now, as I dig in further to the packets, I can identify the application. So it's RTP traffic, streaming media, along with the raw packets themselves, where I can see all the detailed data for the packets. And then likewise, with over 20 years of experience in the packet capture and analysis segment, we can look also at the event logs and the event summary, where we can see very quickly and easily that there's a low MOS score, that there's packets out of sequence, as well as excessive packet loss detected. So in today's session, we focused on SD-WAN Day 2 operations. We reviewed how network engineers can find detailed network information in the engineering console and leverage the powerful logical topology, which really helps to recreate the mental model of the network engineer. We also walked through several use cases in our operations dashboard, or the web UI, where we can quickly and easily see an overview page. And also a very easy to understand geotopology, where you can get details about application traffic along with site performance and tunnel performance. We're only touching just the surface of the capability within Livenex. So I encourage you to please reach out to us for more information or schedule a demo with our team for a deeper dive. Thank you very much for spending time with us, and have a good rest of your day. I'll turn the session back over to Monique.
Thanks so much, David. So with that, why don't we go ahead and open it up for questions? See that we've got a couple of questions here in the chat. The first one is this is Cisco SD-WAN data, specifically jitter. Is it derived from IPFix as well or queried from vManage BFD stats?
Yeah, thank you so much for the question. Yeah, so the Cisco SD-WAN tunnel performance from BFD is derived from our northbound API connections directly to vManage. So that's how we're driving all of those workflows from a tunnel perspective. But like we also showed in the webinar, we also get per conversation and per application performance metrics via IPFix as well. But primarily for the tunnels, it's all derived from BFD via the API connection to vManage. Thanks for the question.
Thank you. Here's the next question. Which features visualizations require packet capture?
So many of the general features and visualizations can be driven by packet capture indirectly. Now, the reason why I say indirectly is that our Livewire packet capture systems can consume packets and then send live flow or IPFix to Livenex for high level reporting and application visibility and network performance. But we also have direct drill downs or cross launches to the packets in our workflows. And was shown in the case of the voice video scenario troubleshooting in the demo, where we went from high level alerts to the flow path analysis down to the packet. So there's many different hooks within Livenex that allow the end user to quickly get to the packets if they so choose.
Thanks, David. Here is one more question. Is all of this derived just from the NetFlow data?
So a lot of the reports, dashboards, and workflows, they definitely leverage flow data like NetFlow and IPFix. But Livenex consumes many different forms of telemetry to holistically monitor and operationalize the network. So Livenex consumes SNMP data. So think of that a lot of times as getting high-level up-down statistics, interface bandwidth, CPU memory details about the device, along with flow, like we talked about earlier. API data via northbound API connections to controllers. So in this case, kind of like with vManage and other controllers. We also have API connections to cloud services like AWS and Azure, and also third-party ticketing systems like ServiceNow. And then along with that, another form of telemetry that we consume is packets like we talked about earlier in the previous question, and that's via our PCA or packet capture and analysis platform. So that's Live Capture and Livewire. Thanks for the question.
Thanks, David. And that seems to be all for the questions in the chat. So with that, I'd just like to leave you with a couple of things, resources that you can have to get more information. So the first is the link that you will receive after this webinar. You'll get a link to watch the session again or to share it with a colleague. You can also request a one-on-one Livenex demo session, and you can also check out the additional resources in the resource tab. Thank you very much for joining today.